Okay, one last thing before we start looking into some examples here. So much like knowing your times tables is an important skill, in this unit it's going to be really important to recognize certain powers. It's not going to be as big of a deal today, but it's not coming less than solving equations. There's going to be it's going to be actually really important. You won't be able to solve the equation without recognizing that certain numbers can be written as powers of a base of 2, 3, 4, 5, whatever. So you should really try and familiarize yourself with different powers of 2, 3, and 4 or 5 up to 12, let's say. So in general here, when I say I want you to know powers of 2, I mean I want you to know, for example, that 2 squared equals 4, that 2 cubed equals 8. And you can sort of follow that pattern down there, right? So, for example, eventually you're going to get to the point where if you see the number 512, it's going to be very, very important to recognize that is actually 2 to the exponent of 9. Okay, so it's going to be important to recognize certain powers in certain situations. So in general, I'd like you to know the powers of 2 up to with exponents up to 10, powers of 3 going with exponents up to 5, for powers of 4 and 5, exponents up to 4, and from 6 to 12 exponents just 2. So again, not necessarily a big deal for today, but do look at some of these powers and try to just recognize them once you see them. So let's just, using that in mind, let's take a look at 625. Let's try and express that as a power of 5. So there's going to be some exponent that you can put on 5 that's going to give you 625. Okay, so eventually I want you to be able to get to the point where you recognize that is actually going to be 5 to the 4th power. Okay, now you can do this with a little bit of trial and error in your calculator. The important thing is here is I actually told you it was a power of 5. Going forward, I'm not going to tell you it's a power of 5, but even if you receive that C625 and know it's a power of 5, you can use some trial and error to at least figure out what the exponent's going to be, but at least recognize that it is going to be a power of 5. So again, that's going to be something important coming up later on in the unit, so just it might be good to start getting some practice for it in now. So with the examples here, I'll do the first one for you, then I want you to try the rest on your own. So just working with these negative exponents here. If you have 3 to the negative 3, in theory you could throw this into your calculator. However, your calculator, if it's a legal calculator for this course, should be giving you a decimal. And we don't want decimals, we want exact values, we want fractions. So you actually should be able to evaluate these without using a calculator at all. So if you wanted to do 3 to the negative 3, what I would expect you to do is to first recognize that if it's a negative exponent, one of the new rules we saw today is that you can take the reciprocal of the base, so you get 1 over 3, and now that exponent is going to be positive. So we 1 over 3 to the exponent 3. Okay, so 3 to the exponent 3 is 27. So we wind up getting 1 over 27 for our final answer. Okay, on a calculator this would give you a decimal. I would not accept that as an answer. It needs to be exact. Okay, so take a minute or two and try B, C, D, and E, and I'll run through them with you when you're ready. Okay, so this first one here, the big thing to recognize here is that this negative is not part of this exponent. Okay, it's only the 5 that has the exponent negative 2, so that negative is going to be left alone for now. 5 to the negative 2 is going to be the same thing as 1 over 5, now with a positive exponent. So now you can evaluate this, 1 over 5 squared. So 5 squared is 25, so you're going to wind up with negative 1 over 25. Okay. For C, we have a fraction here, so we're going to first, to deal with a negative exponent, take the reciprocal of that base. So now we're going to get 4 over 1 instead of 4, or instead of 1 over 4. So this will now be a positive exponent. Okay, 4 over 1 obviously reduces down to 4, so this becomes 4 to the exponent 3, which is 64. Okay, for D, we're going to do the similar type of idea. We have a negative exponent here, so we'll take the reciprocal. We'll get 7 over negative 4. And now it's positive 2. Okay, and then one of the rules we saw back in grade 9 is that now this exponent distributes to both the numerator and the denominator. So this will be 7 squared all over negative 4 squared. Okay, 7 squared gives me 49. And negative 4 squared, that negative gets squared as well, so we get 49 over 16. Okay, and last but not least for E, what's inside this bracket here looks absolutely horrendous. In fact, I think your calculator actually gives you errors if you try to evaluate any of these, but the big thing to notice here is that little exponent of 0. Anything to the exponent 0, no matter how ugly or crazy it is going to be equal to 1. Okay, let's practice another one here. So this is a typical type example you might run into. You can't necessarily do this on your calculator because all the bases are variables. And as a rule, it says here to express this with positive exponents. That's going to be a good rule of thumb for final answers in general, because we don't like negative exponents. We want to write them as positive exponents. So what we can do here, here we have a to the negative 3. We want it to be a positive exponent. So if you want to think reciprocal, that also means moving it to the denominator of the fraction here. So if we want to make this a positive exponent, we can take this a to the negative 3, move it down here, and now that exponent will be positive. Conversely, with this d to the negative 4, we can now move that up to the numerator of the exponent to now have a positive 4 instead of negative 4. So what's this going to look like? Well, I'm going to have my b to the 7. That's not changing. Okay, that's already a positive exponent. There's no need to change it. This d to the negative 4 has moved up to the numerator, so now the exponent on that is positive. Okay, a to the negative 3 is moved down to the denominator, so now it's going to be a cubed down there, and that c squared hasn't changed. That's still hanging around. Okay, so now in one step here, now made this all have positive exponents. Okay, moving on here, looking at example 4. So this one wants me expressed as a single power first before I evaluate. So I'm not going to worry about the final answer yet. I'm just going to use my exponent laws to try and simplify this. So I have 3 to the negative 2 divided by 3 to the exponent 4. Now, notice that these bases are the same, and they're being divided. So if I divide by powers with the same base, back in grade 9 I learned I could subtract the exponents. This is going to be the same thing as 3 to the exponent of negative 6. Okay, so now I have expressed this as a single power. Now I can evaluate it. So to evaluate this, it's a negative exponent. I'm going to write it as a positive exponent by having 1 over 3 to the exponent 6. Okay, I can look at 3 to the exponent 6, and that's going to be equal to 729. So now I've evaluated it, and I'm done. Okay, now with b, the expressing as a single power first is not necessarily as easy. So you'll notice here that the bases are different. We have a base of 2 and a base of 4. So I can't do this blue part right now, the express as a single power, because I don't have the same base. However, going back to one of the things I asked you to do was to recognize certain powers of 2, 3, 4, 5, 6, whatever. We can actually take a look at 4 and think, okay, if this were a power of 2, what would the exponent be? So you might be able to recognize that 2 squared gives me 4. So I can actually get the same base if I replace the 4 in the equation here with 2 squared. Okay, if I do that, I'm going to wind up with my 2 to the 13 has not changed. I'm going to replace 4 with 2 squared, and it's also now still to the power 5. So again, I haven't actually changed anything in the equation. I've just replaced, rewritten 4 as 2 squared, because now these all have the same base. First in the denominator, I can use my power of a power rule to multiply those exponents together. So I get 2 to the 13 over 2 times 5 is 10, so 2 to the 10. Okay, and I still haven't written as a single power, but now I can use my division rule to subtract these exponents. So 13 minus 10 gives me 3, so it's 2 to the exponent 3, which then I can evaluate to give me 8. Okay, so don't necessarily assume that you can't simplify just because the bases are different. Check to see if the powers can be written with a different base. Okay, if you can put them into a common base, then you can use some of the rules that we've seen back through grade 9. Alright, last two. These ones can be a little bit tricky. Okay, I want you guys to try them on your own first. You might want to be very, very careful here with how you distribute these exponents here. So one thing you remember from grade 9, you have 2x to the negative 2, all to the power 2. That exponent distributes to both the 2 and to the x. Similarly here, this negative 3 will distribute to both the 3 and the x to the 4th. Okay, so with that in mind, I want you to try and simplify a as much as you can, and then simplify b, and we'll run through the answers when you guys are ready. Okay, so you can take a quick second and check your answers, but we are going to talk through them because there's a lot going on in these problems. So again, I mentioned you should distribute the exponent through each of these brackets here. So that's going to give me 2 squared and x to the negative 2 squared. Now the power of a power tells me I multiply the exponent, so negative 2 times 2 gives me an exponent of negative 4. Similarly over here with the second bracket, I have 3 to the exponent negative 3, and for the exponents on x, 4 times negative 3 gives me negative 12. Okay, so what I then did is I just sort of grouped my coefficients together and grouped my x's together. So I had 2 squared here, which was 4. Then I had 3 to the negative 3, which we did that example earlier. But remember, 3 to the negative 3 would be 1 over 3 to the positive exponent 3, which is what gives me the 1 over 27 that goes right here. So I just grouped those together, and then I put my x's together. It's x to the negative 4 and x to the negative 12. So then I multiplied my numbers here, my 4 and my 1 over 27 to get 4 over 27. And here I had two powers of x multiplied together, so it's the same base. That tells me I can add the exponents. So negative 4 plus negative 12 gives me negative 16. Okay, and actually I've simplified this a lot. The only thing I need to do here is I did ask you to express your final result with positive exponents. You can expect that to be the norm in a lot of questions you're going to see on tests and quizzes. So just to take it one step further, if I want positive exponents, I can have to rewrite x to the negative 16 as 1 over x to the exponent of 16. Okay, once I've done that, I can now multiply these through, just simplify it a little bit more. So 4 times 1 gives me 4, and putting 27 times x to the 16 to create my denominator here. So overall, I should wind up with 4 over 27 times x to the exponent of 16. Okay, for the second one over here, I did the same thing to start. I started distributing this exponent through each of these brackets. So for the first one here, I had m, negative 5 times 3 gives me negative 15. For n, 2 times 3 gives me 6. Okay, now for the second bracket over here, I had 3 things distribute this power of 2 here. So 2 squared gives me 4. M to the exponent of 2 times 2 gives me m to the 4. And n squared is just n squared. And finally, in the denominator, I have 4 to the exponent negative 1, m to the exponent of 3 times negative 1, which is negative 3, and n to the exponent of 4 times negative 1, which is negative 4. Now, had I wanted to actually, and I probably could have done this, is move this entire bracket here, because this entire bracket is to the negative exponent negative 1. I could have actually moved it all up here and made it a positive exponent and had 4m cubed n to the 4th to the exponent positive 1, which isn't really needed because the exponent 1 doesn't really do anything, and then had it all multiplied it through the numerator. Okay, I didn't do that, but that was something I could have done because, again, this whole bracket here is to the exponent negative 1. Okay, so something to keep in mind is another potential option here. Okay, so then from here I just went to simplify. So I just brought my 4 over here, and then here I grouped my m's together. So I have m to the negative 15 times m to the 4. Negative 15 plus 4 is negative 11. I have n to the exponent 6, n squared. 6 plus 2 gives me 8, again, because those are multiplied to add the exponents. Okay, I kept my denominator the same. And then what I did is I just did some division here. So I have 4. This is actually 4 to the exponent 1 here. Is an invisible 1 here. So here I'm dividing. So I subtract the exponents. 1 minus negative 1 is 2. So it's 4 squared. For my m's, negative 11 minus negative 3 is negative 8. And then for n's, 8 minus negative 4 is 12. Okay, so I simplified that. And I'm just about done. I can simplify that 4 squared to get 16, but I also remember I want positive exponents. So m to the negative 8 needs to be put down to the denominator to create a positive exponent of 8. So I wind up with 16 times n squared. Okay, just grouping the 4 squared and the n to the 12 together. So I have 16 times n to the 12, all divided by m to the exponent 8. Okay, so this is going to be pretty tricky, and they do take a lot of practice, but the rules are, once you apply the rules a bunch of times, you'll see a lot of familiar patterns there. Okay, so there's practice there, and then next lesson we're going to look at different types of exponents again.